Can you introduce yourself, Pradeep Das, and someone with student ID? So, Bima Kharve, what you do in Mumbai division? What's your role?
Currently, I'm working in in administration section.
Okay.
Precisely working in R&D section for reducing the receipt and dispatch, doing the computerization and going to the maximum dispatch by mode of computers.
Okay, that's great. Oh, can everyone see my screen?
Yes, sir.
Okay. So you are familiar with our university if you are in Mumbai, right?
Yeah.
It's in Ville Parle, NMIMS University.
Okay, I stay in Thane.
Yeah. Okay. So I welcome you all. Myself, Dr. Sriyogi Kotala, working as a assistant professor in Department of Operations in the School of Business Management at NMIMS University, Hyderabad campus, which is located some 90 kilometers away from the city. It's in Jechella. So I am associated with this university from the past 2.5 years, let us say almost. It will be 3 years in coming 1 month. So I do teach MBA students as well as UG students. Okay, there's a bachelor's of applied statistics and analytics as well. Okay. So I guess we can start. So I think this is the day 4 or day 3.
It's a day
of your
4.
training.
It's day 4.
Day 4. Okay, great. So
Tomorrow
I guess
is last day.
some things by okay. So some issues may be good out taught by some of my colleagues like Mangal Rao or Professor Narendra or Professor. So I will be taking the prescriptive analytics. Okay. So this is my bio sketch. I have done my PhD from Indian Institute of Technology, Roorkee, Uttarakhand, and Masters in Industrial Engineering and Management from one of the premier tech school in Indore in Madhya Pradesh. Okay. So it's an autonomous institute, and then Bachelor of Technology in Mechanical Engineering from one of the State University of Andhra Pradesh, that is Acharya Nagarjuna University. So I have almost more than 10 years of teaching experience. I worked in both private as well as some central institutes of India, and I also have been to Germany as a part of my postdoctoral research. It is a mobility program from Asia to Europe. So I worked with one of the research cluster called log dynamics. Okay, it is a multidisciplinary cluster and associated with faculty of business with one of the professor, Dr. Herbert Kodza. So I do talk today about a simple way of doing this linear programming Okay? You don't write any program. Okay, you may be knowing how to do things if you are, let us say, using the computers from past few years. You may be knowing the Excel, right? So we can do something about using the Excel to solve some linear programming problems, as well as some transportation problems, like your Indian Railways classic example of Indian freight, okay, where you do transport the goods across the nations with very low cost, let us say, as compared to the private logistics service providers, and liability as well. Okay, so and if time permits, I guess I can adjust the time. I will demo some software called Quora, where it is of a graphic user interface. Okay, you just fit the values and you can see the results. You can change the values again, you can see the results, something sort of a simulation, right? Hope everyone can hear to me. It's okay, my audio. Yes, we have only three. One, two, three. Sorry. You can hear me, right? Can you hear me, Vibha?
Hello?
Yeah, can you hear me?
Yeah, yes, sir, audible.
Okay, okay, right. So what is the decision making? Okay, we do take a lot of decisions in day to day, your personal life as well as in your office life, or you can say your professional life, or in your job responsibilities. Okay, so sometimes you may be taking some difficult decisions. That's maybe something in uncertainty conditions. Okay, that means you don't have any options, or you have to pick up some option forcefully. Okay, and you are worried about its output. So this decision making is regarded as one of the mental process resulting in the selection of a course of action among several alternatives. That's a simple example is, I toss a coin, what will be the head? You will be choosing your option as or your choice as tail or head. Okay. So if you have a choice of head, if you got it, yeah. So if you get an head, let us say, if you say head before tossing it, so after tossed, if you got the option of head as an output, you are a good decision maker. That's how we evaluate. So similarly, when we have more than three options or the three choices, you will be picking up the one. So if it happens good, you are the good decision maker. But every time it will not happen as per our choices. Sometimes it deviates, right? So this is what the process of making a choice between a number of options and committing to a future courses of actions. So hello, చెప్పండి. Yeah, sorry. So there are some various steps involved in this in the making. First thing, we will start with the identification of a problem and identification of a decision criteria. Okay, and there is some concept of allocating the weight to the criteria, developing the alternatives and analysis of the alternatives, and the selection of alternatives, and then you try to implement the best alternatives. Now, if we take an example of, let us say, you would like to buy a mobile phone, okay? So in your hand, you have the budget of 10,000. So with reference to this 10,000 budget, how many number of models that are available in the market? Let us say you have more than 10 models that are available, because the mobile market, electronics market, especially mobile market, is very dynamic. So we have to understand which criteria is the most important criteria for you. Let us say you want to go with an multi-SIM model, you want to have a good camera, you want to have a good night vision camera, you want to have a lightweight, let us say, and you want to have, let us say, a high battery life. It means you charge for once, it should give more number of hours if you talk on the calls. So that is something weightage to the criteria. So let us say you write here the battery life as your top priority. Second priority is of office applications. It should take. Let us say you can write the mails, you can do the messaging using the various social media apps, and you'll try to assign the different weights. That's what this allocating weight criteria. And then you will try to develop the alternatives. Which one I should get the best one within your budget. Among your budget, you will try to choose, and then you will implementation means you purchase that mobile. Okay. Later you will see how effectively that mobile is working. That is evaluation of your decision effectiveness. So this is a simple decision making process. So it's just elaborated, identifying the problem. You will see how, who, why, when, what, and where. These are the questions to be posed in identifying the problem. Okay. So coming to our today's is meaning the size acquired result from this by which pattern of variation is observed. Okay. So I will give you a classic example. Let us say if someone can respond to my questions, that will be very nice. Okay. So how many of you, let us say, travel in a particular noted express trains, let us say in your Indian Railways itself? Hmm? There is only one student.
Hello,
And
sir.
yeah.
Can you repeat it? Your voice is little bit less audible to me actually. Might be having a issue with my
Okay.
internet.
Right. Yeah. Let us
Can you
say
repeat, please?
you have a different prestigious trains, right? Let us say Rajdhani. Okay. So Grand Trunk Express, Tamil Nadu Express, Kerala Express. So why these express trains are so popular? Any one reason?
Giving the additional services,
Okay.
comfort level,
Okay.
personalized attention,
Okay.
and fastest.
Yeah, that's my keyword. Okay. Fastest, let us say. Fastest and reliability. Okay. It is a fastest as well as a reliable in the sense we can say if it starts at some 6 o'clock, and if your timetable says that it will reach the next day morning at 7, sharply it will reach by 7 or within plus or minus 5 minutes, let us say. Okay. So if you understand the pattern of this train reaching the particular destination, you have some precision. Okay, that's what these trains are so popular. If you, I guess everyone do agree with this, right? So if you talk about some prestigious in the sense, the popular trains which people do refer, let us say. So they will reach the destination and they will say that this train will reach the destination. But how they have said is nothing but a simple part of our analytics. Okay? You try to observe the pattern, how this train every day reached the destination. That is what you call it as a pattern of variation. Okay, so this is what you call it as an analytics. By studying this pattern, we understand the future and also predict the uncertainty that is related to the business. Okay, in this it's in this business, we cannot say it's as a business. It's not so highly profitable in the sense, not much profit margins, but we can say it's of a business, societal business, let us say. So for this, we will try to use sophisticated models and techniques, and we highly use the statistics and mathematics as well as the economic models. But we don't teach. I don't teach now for the day a high part of statistics or high mathematical derivatives or the high economic models, but we will try to see some basic models. Okay. So this is what, how do you go about an analytics? Like you gather a data, as an example of a commercial entity, you collect the data from enterprise, social media, internet, and various other platforms. And you club all this data together to consolidate and organize it. And while analyzing this organized data using some data visualization techniques as well as statistics. Data visualization techniques are nothing but a simple things which we do in Excel. That is a bar chart, pie chart, okay, line graph, a histogram, and maybe of Pareto diagrams. So these are the visualization tools, let us say. So we do talk about these things. Let us say, give me a moment. Yeah, I have a prescriptive. I do talk about this today. We could have seen the predictive. You could have seen. I don't know whether they have taught you the diagnostics. And this is a simple one, descriptives. In day-to-day life, you generally do these descriptives. Like your superiors will ask what happened. Okay, so you will make the reports, computer generated a report and automatic alert, and then you will try to map it. That is of a descriptive. Generally, you have a mean, mode, standard deviation, and then variance. If you have some basket of data, you can do that using the descriptives. And then diagnostic, why did it happen? You try to understand. You will try to post some queries. Okay, you use some various data mining and statistical analytical tools. This is the most important, where the majority of the business firms do focus nowadays. What will happen is the forecasting, okay? Because they would like to understand the future. Like if you can see the current, if you understand the current situation, pandemic situation, the majority of the companies' forecasts have been failed because it's the world is of a standstill from the past, let us say 1 year, during this what you call the phase 1, phase 2, or the first wave, second wave of this corona. The majority of the manufacturing companies, even Indian Railways, have stopped it, right? Its activities, let us say. Slowly they are trying to restoring it. So in that way, the forecasting has went under wrongly, right? Because due to these situations where these forecasters would not be able to assess what can happen with this kind of pandemic situations. However, they will try to do this business forecast, and they can use some machine learning techniques. This is what you call it as a predictive. Now, how to make it happen? Optimization, that is the things which I do have in my hand. Okay, this is my, what you call it as an input output model of any business firm or any organization. Okay, I have some inputs, 5M, that is a man, machine, or the human being, machines, materials, methods, and money. And I will do some transformation process here. Okay. And at the end of the day, I have an outputs, or let us say goods or services, in the name of output goods and services. Now, what do you mean by this optimization? We do talk about this optimization, okay? Where you can apply. You can also apply here at this page, that is at the input level, and I also can apply at the output level. Okay. So what you generally try to do, inputs will be minimized and outputs are maximized. Okay. So this is of business, let us say profit and minimization of your resources, your manpower, your machine time, materials, your money, and your method should be economic. So that's why it's a concave and convex function, like what you is nothing but a minimum and maximize. The outputs are maximized. If you are trying to lose your business, you will try to minimize it, let us say. Okay. You don't want to lose much loss. You will try to optimize the loss there also. That's what this prescriptive thing will do. Okay. That's what the prescriptive analytics do. So a simple 4 stages in any analytics, that is descriptive analytics. We will talk about this descriptives. How many students dropped out the last year from some government school? Okay, so you have some numbers. You have to analyze diagnostic tools. Why was the dropout rate increased in the last 1 year? Now, if you map this issue to the current situation, across the world, they say that almost 1.6 billion students have been affected. Like if you take the case of Mumbai, almost more than 1 lakh students have dropped out from the school, especially in the class of 9th and 10th due to the pandemic situation. Okay. So this 1 lakh, the diagnostic is the pandemic. Why was the dropout rate? And in this predictive, with the help of the analysis which you have done in these previous 2 stages, descriptive and diagnostic, this will try to answer the unforeseen phenomena, like which students are most likely to drop out. Now, if you put aside the pandemic situation, there's one of the example which I would like to cite. Let us say some of the students who have dropped out in the interior parts of Karnataka, where these children have been enrolled by those teachers by promising the midday meal, let us say. Okay. So once this midday meal was stopped, some people have dropped out. Okay. So they understood that one of the reason was the midday meal. And the students are most likely to drop out due to that. Because the societal problem here is, let us say, not let us say, because this was what happened. Both the parents are going for work. Okay, they are working. They are going to work in some nearby fields or nearby factories, and they are sending their child to the school such that they get a free meal. And once the meal was stopped, they have started thinking to take back the child to the work. That may be the one of the reason which they found it, and which it affected the passing out rate from that particular school. Passing out means the one who has passed the 10th class, let us say. So this prescriptive analytics will try to analyze and what kind of action you can take by looking at the phenomena. Okay, so which students should I target to keep out from dropping out? So as I said, some machine learning algorithms, we have some supervised, unsupervised, and then reinforcement learning. And when you talk about the data with the labels, there is a classification. Like in your emails, you get some spams. You can do the speech recognition, which is a supervised learning. And simple regression, simple stepwise regression, like you can predict the stock markets and you can predict the rainfall. This is a supervised learning. And in the unsupervised clustering, like identifying the fake news from the social media. This is an unsupervised learning, market basket analysis. Okay, so these are some of the examples. Just I would like to give an idea. Now, in this optimization models or in this prescriptive analytics, we do talk about the model development. Okay, the model development can be iconic, analog, and mathematical. Okay, but we do talk about mathematical today. Okay, only mathematical, a simple mathematics we'll try to use. Let us say some equation, everyone, if you know, some linear equation, ax plus bx plus c, let us say. Okay, or ax square plus bx plus c. There is a square here, so it has a degree of 2, and it is a non-linear equation. And if my degree is 0, or if I say 1 degree, that is a linear equation. Okay, yeah. Now what is an iconic and what is an analog? So a child truck, toy truck is a model of a real truck. So this is a scale model. Okay, and the model aeroplane and the toy trucks are example of physical replicas. These are the iconic models. And then analog models, like if everyone may be using your two-wheeler, the speedometer of your automobile is an analog model, and the position of the needle on the dial of the fuel indicator, it will show whether the petrol is full or empty, are representing the speed of the automobile. Thermometer, which is using another analog model of representing the temperature. And the type will be, you primarily be studying includes representations of a problem. Okay. Now, if you observe current situation, one of the professor from IIT Kanpur has predicted that how the cases of COVID-19 will rise and drop. And they're also trying to predict not so accurately when these waves do come, first wave, second wave, and then third wave, based on some data. Okay, so we have a representation of a societal problem in which they made some sort of a modeling using the symbols and mathematical relationship and expressions in which నువ్వు ఎందుకు అలా డిస్టర్బ్ చేస్తున్నావు క్లాస్ తమాషాగా ఉందండి మీకు మనీ పాట లేకుండా దూరిపోతారు లోపల yeah, sorry. So those are the high-end mathematical models which these social scientists, we can say, are statisticians, which they have predicted. Okay, so this is a critical part of any quantitative approach to decision making. Of course, we also do a lot of this mathematical modeling. I will teach you today how to do a mathematical modeling. Some of the developed models, I will share it with you, and how to run it using the Excel. So this is what in the literature or in the academics, which we do call it as an operations research, and it can also be called as a decision sciences. Okay, so this is a representation of a real world systems. Like as I said, the pandemic situation is a real world system, and we try to model it how this affecting this disease of a particular population, how many number of cases it will give. So they observed it using some statistical models. Okay, so they have developed some algorithms with a view to optimize it, because precautionary measures latter part, the government has to take the precautionary measures. This is a very typical societal issue. So here we do emphasize on the typical deals with decision problems, different types of decision problems that can be tackled using this operation research as a subject. We have to make these mathematical models, which you have one, two red things. Okay, I'm just trying to count these red words: decision variables, constraints, objective of function, and then solution. Now, as we try to understand the concept of decision making, okay, we have some decision variables. While doing the mathematical modeling, these decision variables are the unknowns which are to be determined by the solution to the model. And when you are trying to do this mathematical modeling, we have some constraints. These constraints do represent the physical limitations of the system. Now, if you want me to elaborate, there is a small company, okay? They have a good number of orders from the market, but they have a constraint, the budget constraints. They don't go for high capital. They have a very limited number of human capital. They have a limited number of machines on their factory, and they have not so high-end technology in order to produce the products. So these are some of the constraints. So while doing this mathematical model, we are supposed to understand what is the decision variable, what are the constraints, okay, which to represent the physical limitations of the system. And then finally, we have one objective function. This objective function is, if I ask you what is an objective of this Indian Railways as a societal issue or as a societal non-profit based organization, let us say, that means they don't talk much about business. They want to transport or they want to provide the transportation network to the people as well as to transportation of goods safely or reliably with very less cost and within the time. Okay, that's our objective function. So for my for any business unit, let us say objective function is your profit maximization or your resources minimization. Okay? In the two ways. That's why it is called as an optimization. Okay? And finally, you will get some solution to these mathematical models. So these identification of a set of variable values which are feasible and satisfy all the constraints which lead to the optimal value of the objective function. So when we do the mathematical modeling, we do talk about these decision variables, constraints, objective function, and a solution, which you call it as an optimal solution. So what is a linear programming, a formulation? Here, it's all variables are continuous. Continuous in the sense it can take the fractional values also. Okay. And then our objective is, as I said, minimization or maximization. And these objectives and constraints are linear. Any term is either a constant or a constant multiplied by an unknown. So if you see, we have some different algorithms in order to solve these linear programming problems. If you see, there is one popular algorithm called as a simplex algorithm. So this is where we can do the application, blending of the products, production planning, oil refinery management, and your distribution network, the transportation model, stock markets, financial and economic planning, manpower planning, blast furnace burdening, and the farm planning. Okay. So I will take a simple example of what you call it as a blending, and then we will see some manufacturing. Blending in the sense, one who is company is manufacturing animal feed. Okay. So in this animal feed, they have to make this grams of 4 nutrients, A, B, C, D, let us say. So this is a feed mix, contains 2 active ingredients and a filler. So 1 kg of feed mix must contain a minimum quantity of each of these 4 nutrients, 90 grams, 50 grams, 20 grams, and 2 grams. So there are 2 ingredients, ingredient 1 and ingredient 2, and this is the cost per kg. So finally, you have to mix this 2 ingredients such that your blending should be optimized. Okay, you should not waste more materials. Let us say more. You should not give more than 90. You should not give less than 90. Similarly, not more than 50, less than 50. So which it takes the cost per kg of 40 and 60, it should not exceed. So material wise, cost wise, you are trying to optimize it. Okay, so how to do that? What should be the amounts of active ingredients and filler in 1 kg of that feed mix? So we will try it as mathematical modeling, where you first consider the variables. The variables here are the kg of feed mix, that amount of ingredient 1, amount of ingredient 2, amount of filler material. So x1, x2, x3 are unknown. Okay. So these always will not be 0, but more than 0. Because if you are making the feed mix, it should be more than 0. So that's why conditions are x1, x2, and x3, which are greater than or equal to 0. So this is something like thought as the recipe telling us how to make up 1 kilogram of a feed mix for the cattle. So I have made it like this: nutrient constraints. These are the nutrient in grams. In nutrient A, 100x1 plus 200x2 greater than or equal to 90. 100x1 plus 200x2 greater than or equal to nutrient gram 90. Similarly, 80 plus 150, 80x1 plus 150x2 greater than or equal to 50. So these are all my nutrient constraints. And then we will try to solve that problem. So we have minimizing your cost of making this animal feed of 40x1 plus 60x2. That is the cost of making this x1, and cost of making this x2 is 60. But how many x1 and how many x2 are to be produced, that you have to find it out. Subjected to, these are my constraints, like 100x1 plus 200x2 greater than or equal to 90, greater than or equal to 50, and greater than or equal to nutrient C 20. Okay, and then this, what do you call it as linear programming model? Because if you see, it is 40x1, not 40x1 square. The degree is 1. It's a pure LP model. These numbers, once if you write it in an organized way in your Excel, and you can solve it. Okay. So these are some of the issues, but I don't want to take all these things. We will try to take, if you have any questions, I will take it up.
Sir, in model development, this iconic, analog, and mathematical 3 divisions, do we follow the same basic procedure for all?
Yeah, we do follow the basic procedures. Let us say, for your question, let us say you want to develop a new product. Okay, they don't go directly with a real kind of a model. Okay, first they will conceptualize the things. They will make the dummy things. They will do the clay modeling. Okay, that's how the product development do. And now with the advent of the new technologies, we can do it using the high-end softwares. They will develop some 3D models using AutoCAD, Pro E, and CATIA, and they can visualize how this product is. Okay. And then once these scientists do work together, they will develop the drawings, and then they will go for a test. They will go for a what we can say initial phase of the model, and later again they will experiment with that model which they have developed. So until it goes for the final production, you call it as a model. Once the final production started, you call it as a product. Okay, so that is what we see in iconic models. And analog models are something which it only represents, which is a part of a product development. And mathematical models, which we are currently doing, as I said, classic model of statistical understanding of predicting the rise of cases in India by one of the professor in IIT Kanpur. Okay. He predicted that how it will go, how it will rise, how it will fall, how much numbers it will affect, and what kind of government should think about it. That's what the mathematical modeling. Okay.
So
Clear?
basically, mathematical modeling can be done used for only real scenario, and rest iconic and analogical for the few means um,
Product development.
which for the products.
Yeah.
Okay.
Right.
Thank you,
Right.
sir.
Right. So now
Sir, there is no audio.
wait, I am just trying to show you
Okay,
one.
sorry.
I'm sharing it. Just tell me whether you can see it or not.
Yeah.
Can you read it out?
Yes, sir.
What is that?
Linear optimization models.
Yeah, perfect. Great. Right. So this is a case of one manufacturing. Okay. So as a we do teach the same to our business students. Okay. Let us say how to take the business decisions involved in manufacturing analytics. There is a director of manufacturing where he is trying to analyze each of the operations and concluded that if the company produce these are the bags of a golf bag. Okay, you know the golfing tournaments which do occur mainly even in Olympics also we missed some medal. Okay? I can't remember. So while these golf players play using the golf stick, there is one guy who will be hanging around the golfer, okay, which is carrying some bags. So these are the bags, what you call it as a standard model bag and executive model bag, deluxe model bag. Okay, so these companies manufacturing two types of model: standard model, deluxe model. And what are the ingredients that go in manufacturing these particular models are each bag will require 7 by 10 hours in the cutting and dyeing. Okay, in the department of cutting and dyeing, it takes 7 by 10 hour. Half an hour in the sewing department, 1 hour in the finishing department, 1/10 hour in the inspection and packaging department. So time taken to produce this medium standard model bag. These are the time constraints. So if you see a company which it has some resources, let us say some machines, lathe machines, drilling machines, sewing machines, and then inspection and packaging department, they may be having some machine. So for producing one bag, these are the time required. And for the deluxe model, it requires 1 hour for cutting and dyeing, 5-6 hours for sewing, 2/3 hour for finishing, half an hour for inspection and packaging. If you try to map this scenario, how many number of manpower required, how many number of machines required, how many number of how much quantity of materials required in stitching these two bags. Okay, so this production information is in this way. Okay, I tried to simple version. So there is a department, 1, 2, 3, 4 departments. Production time, as I said, it is a production case. Standard bag 7/10, half 1, 1/16, 1/6, 2/3, 1/4. This is a real world situation. I am trying to convert into a mathematical model. Now, this production is constrained by a limited number of hours. Okay, what are those limited number of hours? They have only 630 hours of cutting and dyeing, 600 hours of cutting and 708 for finishing, 135 hours for inspection and packaging. That is available for production of these 2 bags for next 3 months. Now, this account produce whatever may be the number of bags, each standard bag will earn $10 as a profit and $9 for deluxe bag as a profit. Now, our question is how many standard bags to be produced and how many deluxe bags has to be produced, considering all these constraints. Sorry, these are the constraints, right? These are the constraints. Okay, this is a real world situation. These are the constraints, and these are my times that are available. Okay, for producing 2 bags. Decision variables we have, constraints we have, objective function also we have. Okay, now we have to develop a mathematical model for this sparring problem that can be used to determine number of standard bags and the number of deluxe bags to produce in order to maximize the total profit contribution. So if you can try, $10 is the contribution towards the standardized bag, $9 of profit contribution to the deluxe bag. You have to optimize this objective function. Clear? Understood? But
Yes.
we are supposed to use only these resources, which are constraints. For cutting and dyeing, I have only 630 hours. Okay, so these are the constraints. I think I should use a different color. Okay, Mohan Pandit, welcome. West Central Railway. Okay, right. Yeah. So these are my constraints. I am red mark. Okay. So these are the time taken to standard, deluxe, standard, deluxe, in the sense of cutting and dyeing, in the sense of sieving, in the sense of situation of finishing, and in the situation of inspection and packaging. As when your company is operating, finally, at least you produce 1 bag. Sure, that means always S comma D is always greater than or equal to 0. Okay. So these are the one of the technique, that is what you call it as a graphical solution. Okay, this graphical solution means we try to represent these equations on a graph. Okay, if you observe, there are 1, 2, 3, 4 equations. If I remove these equations, if I remove the inequality sign here, let us say here, if I remove it, if I put it equal to, and I will put S is equal to 0, I can find the values of D. Later, I can also find the values of S. So this line, this equation as a line can be represented if I find the values of S and D. Similarly, if I find the values of S and D for this equation, I can represent it as a line. Okay, so 1, 2, 3, 4 lines I can represent. These are those lines. Okay, so this is the finishing line. At 1050 to 670, let us say. Okay, if you want that exact values, if I put S is equal to 0, B will be 630, and if B is 630, you can also find out the value of S. That's a simple logic. So we have 1, 2, 1, 2, inspection and packaging, cutting and dyeing. So 1, 2, 3, 4 lines which have intersected at this point. So this point is my optimal value. Okay, but if you observe, when I have only 2 variables here, okay, I have only 2, S and D. So as a graph, only 2 axes, X and Y, you can only represent when you have 2 variables. That is the limitation of this graph. So by looking at this point, I can say that at the point of 250 and 350, if I sell 350 standard bags and 450 deluxe bags, I can optimize my manufacturing scenario. That means I can optimize my objective function. Okay. So finally, I try to find out what is the values of S and D from my graphical solution. Okay. Any questions on this? You can try using pen and paper if you want. Okay.
So why we are taking only two variants? Means you showed only one point. There are four lines, no? So
Yeah.
why we are taking only two intersection of only two?
Because this is something of equation of a straight line. Okay, let me show you. This is 7 by 10 S plus 1D less equal to 630. Okay. 7 by 10 plus D is equal to 630. Okay. I want to put D is equal to 0. So 7S by 10 is equal to 630.
So S
So S कितना होगा?
6300 by divided by 7.
Right. So I got one value of S. If I put the S value here, I can
I
get
get
the
the
value
value
of
of
D.
D. Yeah.
Right. So those two values you can represent it on the graph.
Yeah. But there are means there are four criteria, no sir? We have four lines that finishing, sewing,
Yeah.
and all
So
those things.
each line you can find out the value of this S and D. So I will get an order pair of X1 and X2, X2, X3 and X4, X4 and X5. So all these lines I am representing it here.
Yeah, but we are choosing only the intersection of one point, no? We are choosing the intersection of
very good question.
IP and CD.
I got it. Right. So now you try to find, like as I said, is from the graph, as is the find of part of a graphical solution. This you have one point. This is also intersected, but it has not taken all the four lines.
Yeah.
Let us say this has also intersection, but it has only 3 lines. So, but if I want to produce, I should follow all these four constraints. I should satisfy all these four conditions.
Yes.
If I am taking cutting and dyeing, sewing and finishing, the product is not yet finished. You should also go to inspection and packaging. So that has happened only at this point, let us say. Okay. Or at, where these all four lines have intersected. So that point is my optimum point. So that point on the graph, you can find out what is the value of D and what is the value of S. If you take those values in this object function, you get the value.
Thank you, sir.
Yeah. Now, you may say, sir, we don't, if I have a 3 products here, let us say, that cannot be represented in graphical solution, in which you should do using Excel, where you write the function of some product. This is the thing which you have to do. Can you do it on your Excel now? Or I will try to show you how to do it, one problem in Excel. These are the values. Okay, let us say, what if spreadsheet model for barring incorporation, like the operations 1, 2, 3, 4 operations for standard bag. What is the time for deluxe bag? What is the time? Okay, I will show you in Excel. Give me a moment.
Yeah. If you can simultaneously share that also, we will try to do it, sir.
Yeah, I will share in a drive, but give me a moment.
Sure, sir. Thank you.
Can you see my screen?
Yes, sir.
Okay. So these are my operations. This is my profit per bag. Okay, standard and deluxe, the time which I got. So this is something which I am trying to put whatever maybe the equations which I got in our from the situations, let us say. Okay, this is what I am trying to represent here. Can you see this?
Yes, sir.
NS plus D. This is profit per bag. This is my objective function. Maximize this profit. Okay. And the standard time, standard bag, I have the time 7/10. So I have written as 7/10. This is 1 hour, 0.5, 1/2, 5/10, 5/6, 1, 2/3, 1/10, 1/4. Okay. And these are my constraints. Yeah, so these are my constraints. 630 hours for cutting and dyeing, 600 hours for sieving, 708 hours for finishing, 135 hours for inspection and packaging for next 3 months. Now this is my point where I should produce. This is okay, solved one. Okay, actually you have to initiate this with 1 and 1. Okay, if it is for 1 and 1, you have to write here 1 and 1. These are the hours that is being used. Okay. Go to the data and solver. Okay. Yeah, you have to write one formula here. The total profit, sum product of profit per bag, comma, considering these operations time. Okay, whatever maybe the constraints which we have, 1.7, 1.33, 1.67, 66, and 0.35. So profit per bag, considering profit per bag, comma, this B4 to C14. Okay, let me. This is an B4 to C14. B14 to C14. Number of bags to be produced. With this profit, how many number of bags to be produced? That you have written the sum product. It takes the two arrays, right? This is the only formula. Now go to the solver. The target cell is my cell B16, which I have to maximize the profit. So you click on the maximization. You have also option of minimization, but this is a case of object function of maximization. So by maximizing, which cells you have to change? B14 and C14. That means how many number of bags to be produced. That is B14 and C14. Like if I click, this is a B14 and C14. Okay. And then you have to add the constraints. How to add the constraints? You take some cell, you change it less than or equal to, greater than or equal to integer and binary values. Let us say this is less than or equal to constraint. Which constraint? 630. And you click on this. Okay. So I got this. These 18. Cutting and dyeing is less than or equal to 630. And then sewing is less than or equal to 600 hours. Finishing is less than or equal to 708. So you are just trying to model this inequality in our solver parameters. So I have already have, I am just deleting it. And then options, you leave it something like this: 100 iterations, precision of 1 0 1, I think. Yeah, tolerance of 5%, convergence of 0.001. You don't worry about this. Click on the assuming the linear model, assuming the non-negative. You click on OK. You click on the solve. Okay, and then you will get 3 reports. Yeah, sorry, I will show you the solving part. So you will get something like this. Click on here, answer, sensitivity, limits, and then say okay. You will get 3 spreadsheet like this. Okay. Answer report, sensitivity report, and limits report. So as a business manager or as a managers, one thing is you came to know this is your profit. If I sell 540 standard bags and 252 deluxe bags, I will get 7,668 bags, standardized bags. Okay. Coming to this, you should be able to understand this. There are concepts called binding and not binding. Okay. If you dig these values of 540 and 242 in our equation here, okay, 540 and 242 in this equation, it should be binding. If it is equal to, generally that will be equal to 630, then that will be a binding. If it is more than 630, or more than whatever may be the value which we have here, 600, it is a not binding. So it depends upon what kind of final values which you got, and if you dig these values in my equations here, you will get this binding and non-binding constraints. Okay. Finally, binding you have the slack of 0, 0, 0. Non-binding you have slack of that is more than 120 and 18. This is our remaining amount even after digging these values in this equation, in which it affects
So,
my
so does that mean, sorry, so does that mean that if ensuing hours used plus of 120 plus minus of 120 is not making any difference?
that's the how you have to interpret it. That's what you call it as sensitivity. Let us say, good question. Let us say I have 480 hours I am using it. 120 I have not used. 708 I have used. I have no more hours of finishing. But I have inspection package 18 hours, which is unused. So, but unless and until if you don't have cutting and dyeing hours and finishing hours, you cannot go for more number of bags. Okay, so that's how you will interpret this sensitivity report. Good. Okay, this is what you call it as a sensitivity report. So this is answer report, which you will know how many number of products to be produced and how the resources have been used by looking at this binding and non-binding constraints versus slack. Okay, that's how mathematically I have just said that you put the values of S and D. If it is equal, binding. If it is not equal, non-binding. That's how the interpretation of this binding and non-binding. Now, as what you have said, these many number of have been used, right? This is how the basic Excel can use in interpreting the what you call the production problem. You can do so many problems if you know the logic of this linear programming. Now I will share you. I don't have a. I will share you a drive for a moment. It will not work for more than 2 or 3 minutes. Try to download it, and I will try to solve some problems. Okay, if you can solve at least 2 problems, that will serve the purpose. Okay, give me a moment. I am just sharing you the link. Yeah, here is the link. Check it out. Can you check it out, someone? Vibha Gopal Kumar. Can you see my message, Vibha?
I have an issue with my internet, looks like. I'm not able to download it. Just one sec, sir. It's from my side.
Okay, can someone else please check it out? Yeah, I have given the permission. Okay.
It was working till yesterday, some issue. Uh, so I'm not able to just one sec, sir. Will
Yeah.
I will ask my Avinash, can you log in your Gmail? Your Gmail. Mine is not working. Yes, sir.
Okay, in the meantime, you can write it down. I will take the, until now we have seen the maximization case. We have a minimization case, okay? We'll see the minimization case.
Yes. Put in my- Here you put in. Yes, I think I managed, sir.
Got those files?
Uh, file class. File
Okay.
class.
Yeah.
Yeah. I have to download all.
Yeah. 1, 2, 3, 4, 5, 6 you will get.
Sure, sir.
You open the par.xlx.
Okay. Okay, sir.
Okay. And try to do what I have done. If you find difficulty, I will help you. If everyone can do, that will be nice. Otherwise, I will move on to the next case.
I will first download all.
Yeah.
Some issues with my. So which one you said? PAR.
PAR, yeah.
Yeah, okay, I got it. Yes, got it, sir.
So you try to run it, okay? See here. Do you have that formula already written? Otherwise, write something like this. Can you see my Excel file?
Just one sec, sir. So many. Yeah, I can see now. Yes, I can see now, sir.
So is there any formula? Otherwise, you write the formula.
Yeah, this is in the total profit.
Exactly.
Okay, sir. Okay. Sorry. There is something written already in that file, so there is
Can you
some.
share your screen?
Yes, sir. Share. So it is already.
Yeah, you try to go to the data.
Yes.
Yeah, now let me tell you one thing, Viva. If I sell one bag of standard and one bag of deluxe, my profit is 19. Okay, that is the meaning of this. Okay, so you have initiated your process of making profit towards making profit. Okay, so how many bags you have to make? Ultimately, you don't make one bag, right? You will make how many? But we will do it. Go to the data.
So I have to make this first one.
No, that's okay. That is one. That's correct. Go to the data.
Which data I should use?
No, go to the file.
Okay, sorry, sir. Sir, I'm not. This is not enabling it.
You enable editing. Okay, we couldn't find. It is possible it was. Yeah, go to the data.
Yeah.
Data analysis.
Okay, I will go to analysis. Yeah.
You don't have a solver. Yeah, no, you don't have solver. You have to.
I have actually, sir. I don't know because the sheet is not enabled, so I'm not getting. Yesterday I saw that solver was there.
Do one thing. You save it as another file name and try to open it.
Okay.
And let me.
Yeah. Okay, sure. No, it is not. It is not enabled actually. So sorry. I will try to download again from the chat. It is not.
Okay, no problem. Try to practice in the meantime. I will try to take the different other case. Okay.
Sure, sir.
Can you see this? So in our answer file, we have seen this binding constraint, okay, not binding constraint, okay. So this is the meaning. One holds as an equality at the optimal solution. So this slack value indicates less than or equal to constraint indicates difference between the left hand and right hand value. That means used and unused. And by adding a non-negative this slack variable, we can make the constraint equality. That means all my resources have been fully used. Now we'll talk about minimization problem. There is a chemical company, okay. The combined production have two products here, at least of 350 gallons. And separately, a major customer's order for 125 gallons of product A must also be satisfied. So to produce this, processing times of product A is 2 hours per gallon and product B is 1 hour per gallon. So for the coming month, 600 hours of processing time are available. So this is something about a case of a refinery or a case of a chemicals, M&D chemicals. So the production cost for A is $2 per gallon and product B is 3 per gallon. You have to optimize. Objective function is minimizing the total production cost. So the problem formulation will be find the minimum cost production schedule. First define what are the decision variables and the objective function. Number of gallons of product A, number of gallons of product B. Objective function is 2A plus 3B. And then constraints are demand for product A is 1A, it should be more than or equal to 125. That's what we have understood from this major customer order for 125 gallons of product A must also be satisfied. That is the first one. Total production time 1A plus 1B should be greater than or equal to 350. And 2A plus 1B is less than or equal to processing time. So this is another constraint. So the surplus variables tells how much over the right hand side and the left hand side of a greater than or equal to constraint is for a solution. Because if you see here, there are some variables, some constraints, okay, equal to greater than or equal to, some are less than or equal to. Okay. So this is my Excel sheet, which I have already sent to you. Otherwise, try to observe how many number of gallons to be produced, product A and product B. We have to minimize this total cost. So my cell of minimizing the total cost cell of B16. And we have this provided of 250 and 350, whatever may be the constraints which I have. Product A and total production. Processing time available is 600. Okay. Compulsory, they will use the 600 totally. So unused hours will be 0. So if you are using the higher version, you will find the dialog box under the solver parameter something like this. Okay. I am using the lower version of Excel. So I will find a different view. Then you will get this report. Okay. So we have product A provided. This is a not binding and remaining are totally used. Okay, binding and binding. So let us do this problem. I will show you again. I will show you that M&D problem. Data solver, solver. So these are my things. Set the target cell of minimizing the total cost cell B16, and I want to minimize this. Okay, not maximization phase. And then by changing the cell B14, C14, number of products of A and products B, which you are supposed to produce, you have to change these cells subjected to constraint B19, that is product A required, which is greater than or equal to, and production required less than or equal to, that is of 23, that is 600. Okay, so this 19 and 20 greater than or equal to 125 and 35. That is the meaning of this one. And this is processing time of 600 used, hours available 600. That is the meaning of this P23 less than. So you have added constraints. Options: assume non-negative, assume a linear model. Okay. And then you click on the solve. You can say on answer report, sensitivity report, limits. So I will get the 3 sheets, something like this. If you have done, let me see. Otherwise, I will describe what I have done. What was how to interpret the result.
So,
Yeah,
which worksheet you are taking, please?
M&D, madam, M&D.
MNJ. Okay.
M&D chemicals करके है, देखो ना एक बार.
Yeah.
M&D XLX or M&D model, both are the same. I got a duplicacy in this.
Sir, we have to do the answer sensitivity and it limits all 3, na? And we have to keep the solution, solver solution.
Right. If you can share your screen, I can guide you.
Sure, sir.
Okay.
Yeah, then date. What happened?
I think it was stuck, I guess.
Yeah, connection is all are working from home.
So is it okay with if you can see? Okay, you stop sharing. Is it happening on your screen at least? The things of adding constraints, minimizing the cell, targeting cells. Could you see that?
Yes, sir. I can. I will try to share again, sir. I think I have that reports also. I will try to share again, sir.
Okay.
God. No. Uh, yes. This thing?
I can't see, madam. I can see only one sheet model.
Okay, now?
No, I think it's taking lagging, I guess.
Yeah, might be. I managed to, I got all the reports, but
Mm-hmm.
okay, I will try to copy paste in, it went up.
Okay, just
It's okay,
no
sir. It
worry.
went off again.
Yeah. Otherwise, you try to match my values. Okay.
I managed to run that, sir, but I think severe problem of this thing. It's not.
You got those three outputs, three
Yes,
reports,
sir.
right?
Yes, sir.
Okay. You try to see here. Okay. This is a limits report. This is a sensitivity report. We are much worried about this. What happens if I increase the price of by 4? What can be the increase in the profit? What can be the increase in the total production provided, which is of 125. Allowable decrease may be up to 50. And allowable decrease of product rates of infinity. Okay, this is something like infinity, which is of general view. If I say of number, it will be something like infinity. Okay. Let us be in general only. So product A allowable decrease is infinity, product B allowable increase is infinity, and answer report. This is what binding is of 2, total production provided and processing times are binded, and product A is not binding, not equal. So we didn't find much scope for improving if you increase or decrease this right-handed side or left-handed side. If you see this, okay. So are your answers or something like this, Vibha?
Yes, sir.
Okay, good. So these are the two cases of maximization and minimization. I have more cases, but I can see only one participant is doing. If the others also could do it, that will be benefiting you. Okay. Now, yeah, can you see this?
Yes, sir.
Yeah, so this is what our output. Everyone got it, maybe you have done. So the sensitivity analysis is like how if I increase the input, how does it may affect the output? So based on the assumption that only one piece of input data has changed, assuming that all other parameters remain as stated in the original problem itself. So, but what would happen if 2 or more pieces of input data are changed simultaneously? This is what the business managers or the decision makers would like to see. Okay. What happens if I change the resources? If I decrease the resources, how does it affect my profit? If I increase the resources, how does it affect my profit? Ultimately, they want to make the profit by minimizing their resources. That's what this sensitivity analysis do address. So, is the easiest way to examine the effect of simultaneous changes to rerun the model. That's what the sensitivity analysis. Okay, I think we have already done this. Yeah. So let us see, I guess, if you have done some investments as part of saving, this is of investment portfolio selection. That means manufacturing, maximum thing we can, manufacturing we can do using any situation we can convert it into a mathematical modeling. You can solve it using a solver in Excel. So this is another classic example that is of investment portfolio selection. Right. So this portfolio selection problem involves situations in which a financial manager must select specific investments. Okay, he has to mix off this specific investment, let us say stock and bonds from a variety of investment alternatives. For objective of investment, always maximization of expected return or minimization of risks in both ways. So you have some constraints, restrictions on the type of permissible investments. You have some state laws, company policies, and so on are the constraints. So this is an investment portfolio selection. So I have investments which you can do using in Atlantic oil, Pacific oil, and steel mixed with oil with petrol with steel, and then government bonds. So my projected return, if I put it in Atlantic oil, is of 7.3, and if it is on a Pacific oil, it's of 10.3, and Midwest steel, it is of 6.4, with the Hoover steel of 7.5, and for the government bonds, it is very less, 4.5. Because this is a mix, we have to mix with this all these 1, 2, 3, 4, 5 investments. So this is a mutual funds company located in New York City, is looking for investment opportunities for some, let's say, $1 lakh. And the firm's top financial analyst identified 5 investment opportunities and projected their annual rates of return, which you can see in this slide. So there are some guidelines in this investment. So neither industry, oil or steel, should receive more than 50,000 US dollars. And that the amount which you invest in government bond should be at least 25% of the steel industry investment. And the investment in the Pacific oil, high return but high risk investment. And that cannot be more than 60% of the total oil industry investment. Now the total oil industry investment is, I think, 1 lakh, I guess, right? Okay. So these are the guidelines which are constraints, let us say. So how many dollars I should get out of Atlantic oil, out of Pacific, Midwest steel, and Hoover steel and government bonds I should investment, such that the maximizing the return conditions are 7.3, 10.3, 6.4. This is the one. Okay, this is the things. This one I will write it in my objective function. Maximize 0.073 of dollars which you have invested in Atlantic oil, 0.103 of dollars invested in Pacific, 0.064 of Midwest, 0.075 of Hoover, 0.045 of government bonds. I have this 1 lakh of investment. It should be, if I am using the petrol, oil, it should be less than 50,000. If I am using steel, less than 50,000. If I am putting on the government band, it should not be, it should be more than 0.25. And my investment together of X1 and X2, it should be less than or equal to 60. This is something from my constraints. Okay, these 4 points, these guidelines, I have converted into constraints. Okay, the non-negativity constraints. Your money will not be into negative. That means it's of a loss. So this is my final fit linear programming model. To maximize these objective functions subjected to the availability of the funds, oil industry maximization, steel industry maximization, government bonds minimum, at of 0.25, Pacific oil restriction at of 60%. So these are my constraints. This is my subjected maximization objective function. This you will put it in Excel. Okay, same thing. So if you have done 2 or 3, you can do as many as possible. Okay, so this is my mutual funds problem. Let me show you the Excel. Yeah. So this is the maximum total return sum product of Atlantic oil to government bonds. I'll just highlight it. Okay, which of the sum of the product it takes. Sum product of we put into it, and these are the sum products which it grows. Okay, and then go to the data solver by changing the cell max total return of this cell. Okay, which it is of already solved, so that should be initiated with some value, and then this is my constraint. B23 is less than or equal to C23 equal to. Okay, my funds invested should be equal to $1 lakh, first constraint, and my oil funds invested should be maximum allowed is B26 to B28 less than or equal to $50,000. Similarly, the government bond should be greater than or equal to $10,000. Okay, so if you want, these are my constraints. I will use a different coding, color coding. Yellows are the constraints. Yellows are the constraints, right? So then I will see the solver options. Okay, solve. I will get these answer sensitivity and limits. So already I have, I guess. I will try to see whether it can see. Okay, so I got it. Answer report, sensitivity report, limits report. Okay. If I see the answer report, the maximum return, if I want to get the maximum return, looking into the conditions, I should invest $8,000. So if I invest the $8,000, I got, see how many non-binding and binding. Unused in oil funds. This is of not binding, okay, and remaining all are binding. Only thing steel funds invested and total funds invested, it is taking inequality. And coming to the sensitivity report, these are my infinity values, allowable increase and allowable decrease, and how the final value will change if I increase in the shadow price by $0.07, $0.02, $0 and 0.03, and it's going of negative onward bond, right? So this is how you can do the sensitivity analysis versus modeling in Excel, which you call it as a prescriptive analytics. Okay, if you have any questions, I can take up. Otherwise, we'll go for a break for 15 minutes. Yeah.
So
Yeah. Yes, please. बोलिए मैडम. वाह. Can you hear me? Yeah. Can you hear me? Okay, once I am back from break, I will address your. అది మన పిల్లలు కాదు, రైల్వేస్ది. చూడబెట్టు. So let us see the next part of the prescriptive analytics application on the transportation problems. Okay. So what is the transportation problem? First, we will see. Yeah, 1 second. Let me share my screen. Can you see my screen? Okay, so this is a transportation models. As I said, the classic example is of a railway street where you transport these various goods or the various raw materials from different sources to the destinations, and how to optimize the routes, how to optimize the cost. Okay, so this is something finding the low cost plan for distributing the stock of goods or even supplies from multiple points of origin to multiple destinations that demands the goods. Let us say one factory may be producing one company may be producing different products in different factories, and from the different factories to the different markets, how do they transport? Okay, how to optimize this costing? So we have a supply, you have a demand, we have to balance this. So in this transportation model, we have a numerous applications like the location decisions, where to set up your plant near to the market or near to the raw materials, the proximity to the raw materials, production planning, capacity planning, transshipment, that is a mix of all the transportation models. So first we'll try to understand what is the transportation problem and then how to solve it using again Excel solver. Okay. So shipping points are the supply points. Okay, factory which you supply, let us say a warehouse which it supplies, or the departments from where the goods are sent. These are all the supply points. And the destinations, any point that receives the goods, let us say it may be again a factory or a warehouse or a market or a department. So you are transporting from supply to the destination. So how to model this? You have a list of the origins and each one's capacity or supply quantity per period is known. And then let me finish this, Viva, and then I will take your
Sure, sir.
doubt.
Sure, sir. No problem.
Right. So we have a list of the destination and each one's demand per the period. And we have an unit cost of shipping items from each origin to each destination. Like if you observe, for any product, the product pricing, it also involves not only the manufacturing but also the transportation cost. So that's why the unit cost of shipping item should also be minimized. So the items to be shipped are homogeneous. These are some of the assumptions. All goods are homogeneous. Shipping cost per unit is same regardless of the number of units which you are shipping. Whether you ship one, you ship two, 20 or 300, whatever, the cost per unit will be the same. And there is only one route or mode of transportation being used from various origins to the destinations. So this is a problem, let us say. There is a cost to ship one unit from factory 1 to factory warehouse A. Let us say I will explain it to you more clearly. Yeah, so these are my factories. I have 3 factories, 1, 2, and 3. And then A, B, C, D are the warehouses, let us say. Okay. And then factory 1 can supply 100 units per period. Okay. And factory 2 supplies 200 units per period, 150 factory 3. So to ship 1 unit from factory 1 to warehouse A, I incur 4 units of cost. Okay, $4 of cost. Similarly, the demand is for A warehouse B is can be 90 units per period. A is 8. So if you sum up all this, it should be equal 450, and the capacity is also 450. If it is not equal, this is not a balanced problem. Okay. So generally, this demand should be equal to supply. If it is not equal, it is an unbalanced. So wherever you are finding the difference, you introduce a dummy there, you put 0, 0, 0, and whatever may be the difference, you introduce it as demand or supply, just to maintain the logic of our transportation model. Okay. So for solving this, we have a different approaches, like the low cost approach, northwest corner rule. Okay, I will show you a video now, because if I use it PPT, it may not go. So let me show you a video. Yeah, can you see this?
Yes, sir.
And the initial basic feasible solution of the following transportation problem using northwest corner method. So here we have three factories F1, F2 and F3 which have a supply capacity of 6, 8 and 16 units per day respectively. And there are four warehouses W1, W2, W3 and W4 which have a demand of 4, 7, 6 and 13 units per day. Now these three factories can supply to any of these warehouses, and we need to find out how much quantity should be supplied by each factory to the warehouses such that the overall transportation cost is minimized. Now the numbers that you see here in black are the unit cost warehouse. For example, for transporting one unit from factory F1 to warehouse W1, the cost is 14 rupees. Similarly, for transporting one unit from F1 to W2, the cost is 25 rupees, and so on. So let us understand this example in more detail. Let's say this is the map of India. Let's say that this is factory number one.
So
Yeah.
No,
What happened?
it was not audible, sir.
No, everyone is not audible.
Now,
Now is it audible? 1 second.
yeah, I can hear you now.
Okay. Do you want me to run again?
Sure, sir. Please.
Can you hear?
Yes, sir. Yes, sir.
Okay. Okay.
Nothing is audible to me. So
Yeah,
I'm not able to see or hear anything.
you are not able to.
Uh, you're sharing anything, I'm not able to. I think I have a severe internet issue.
You cannot hear as well.
I'm not able to. Yeah. Yeah, now I can.
Yeah. I think in between my net also gone. Okay.
Okay.
This is the problem. How to solve the problem? Let us see. Okay.
Sir, no audio.
It will come. It will come. Can you hear me?
Yeah.
We are writing something there now.
There's still no audio for me.
Sorry.
I'm not getting any audio. We are just watching this clip.
The supply.
Now,
So we'll move
Yeah.
to the square on the right hand side, which is F2W3. Now for this square, the demand at W3 is 6 units, while the supply capacity at F2 is 3 units. So we'll allocate 3 units here, and with that the demand at W3 becomes 3 units, while the supply at F2 becomes 0. Now, since the demand at W3 has not been completely satisfied, so let's move to the square down below, which is F3W3. So here the demand is 3 units while the supply available is 16 units. So let's allocate 3 units here. So with this allocation, the demand at W3 becomes 0 and the supply becomes 16 minus 3, which is 13. Now since the demand at W3 has been completely satisfied, but the supply at F3 is still remaining, so we'll move to the right hand side, which is F3W4. So here for this square, the demand at W4 is 13 units, while the supply available at F3 is 13 units as well. So we can allocate all the 13 units here to this square. So with this allocation, the demand becomes 0 and the supply also becomes 0. So now if you note, all the demand and supply situation has been allocated. So let's find out the transportation cost for this solution. So we have from to number of units shipped, cost per unit, and the total cost. So the first allocation is from F1 to W1. So F1 to W1. The number of units that we have allocated is 4. Cost per unit is 14. So the total cost becomes 14 multiplied by 4, which is 56 rupees. So this is in rupees. The next allocation is from F1 to W2. So F1 to W2. The number of units shipped is 2. The cost per rupees is F. The next 195 rupees. So now the total cost is the addition of all these. 5 plus 5, 10 plus 2, 12. 3 carryover. 3, 4, 5, 6, 7. 726 rupees is the total transportation cost which we have achieved using the northwest corner rule for this transportation problem. Now again, this is
okay,
not the
this is
optimal
how we
solution.
will have to solve. Okay, but we have only 3 factories and 4 warehouses. But if we have 10 factories, 10 warehouses, so it will be tedious to do using pen and paper. Okay, but this is the logic. We have different other methods as well. Let me share it. Yeah. So this is the one. You see, there are methods don't do it manually. We'll try to do it using Excel again. Okay. Let me give me some time. Okay, some time. Let me share you. Where is this? Can you see my screen?
Not yet. Yeah.
Okay.
Yeah. Yes, sir.
So, yeah, this is the one about a transportation problem again, but I will do it using Excel. Okay. So these are this is the problem. Actually, there is a foster generators. They have a transportation of a product from 3 plants to 4 distribution centers to determine how much of its production should be shipped from each plant to the distribution center. So there are 3 plants at Cleveland, Bedford, and York, which is in the US, and the production capacities are 5,000, 6,000, 2,500 units. This is for the 3-month planning period. Okay, and the 3-month forecast for the demand for the distribution centers at destinations like Chicago, Boston, St. Louis, and Lexington. We have 6,000, 4,000, 2,000, and 1,500. So the capacity is equal to the demand forecasted for the 3 units is equal 13,500 and 13,500. Now you have to model this situation. So these are the various plants, that is at origin nodes to the various destination nodes, and the transportation cost per unit on the arrow. If you can see, let me show you once again. I will pinpoint it correctly. Yeah. So this is my transportation cost to ship from Cleveland to Boston. Similarly, Cleveland to Chicago, $2 per unit. $7 per unit from St. Louis. Okay, so these are my supplies at this side: 5,000, 6,000, 2,100. This is my demand at the destination nodes, and these are the distribution routes. This is a typical transportation network look like. And our objective is to determine the routes to be used, like your quantity to be shipped via each road should be minimum, right? Finally, your cost should be optimized. So if I am shipping the number of units from origin I to destination J, I will be 1 to 2M and J will be 1 to 2M. Okay, some mathematical representation. So if you put it in a table, let us say destination and origin, these are the various costs associated, transportation cost associated, and the supply constraints are Cleveland supply, Bedford supply, York supply. Supply constraints, demand constraints are Boston, Chicago, St. Louis, and Lexington. So we are trying to model this transportation problem into a linear programming model. That's it. Because in Excel, finally, this linear programming model, we will put it in Excel. Okay. This is a long, see how many variables we have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 unknown, 12 decision variables, and 1, 2, 3, 4, 5, 6, 7 constraints. Okay. So this sheet also I have shared it with you. Foster's Excel. Okay. So you try to do it on your own now. Okay. Then I will show my Excel output. So these are my origins to the destinations from Cleveland to Boston, whatever may be the unit cost, the supply and demand is equal. I have to minimize the total cost, some product of origin to destination versus whatever may be the number of units, that also has to be written in this Excel. Okay, so if you can go back, let me open my Excel sheet. Give me a moment. Where is my Excel? Yeah. 1 second.
Can you share the screen, sir, please?
Wait, madam. Wait. I'm trying to find my Excel. It's not showing it. Excel. Why they can't? Yeah.
Sir, I managed to solve.
You try to manage. I don't know why I could not be able to.
I think I managed to solve. Sir.
Can you see my screen?
Check.
Yeah. Vibha, can you see my
I
screen?
just,
So this is my target cell,
Yes,
which
sir.
is of total cost cell of B13. I have to changing the cell B17 to E19. Okay, these are the number of units that are supposed to be transported towards from origin to the destination. So some product of total cost versus number of products to be transported, and subjected to the constraints like B20 to E20. B20 to E20 are my total number of products which I have to send from origin to destination, 6,000, 4,000, 2,000 to 1,500, which is equal to these two cells. Okay, let me close this. These are my constraints. Okay, this is one. I'm just highlighting, and this is another one. Okay, and I have to change this cell by changing this cell. Now, if we will go back to the solver, these are the things. Again, you should also make sure that your constraints of Cleveland, but New York versus whatever may be the demand at the various destinations. That is B17, F19, this one, this black, 1,000, 4,000, 0, whatever may be the value. Yeah, so that should be less than or equal to supply, that is 5,000, 6,000 and 2,100. Now go to the options. Again, assume linear model, assume non-negative. Okay, you solve it. You'll get 3 report sensitivity and answer limit. You click on the OK. So you'll get 3 reports, right? So my answer report finally, I will have to incur some $39,500 for transporting from various sources to the destination. And I got some very good not binding, 4 not binding, and only 3 binding. So how to improvise my destination to Boston, Chicago, St. Louis, and Lexington, you have to explore. And coming to the sensitivity, how does this final values do affect if I increase by price of 6,006? That allowable decrease will be 2,500. And then by 5, it will be allowable decrease is 2,000. So this is how we can do the sensitivity analysis. Okay. So if someone can share, I will try to have a look. Can anyone share?
I'm trying to solve.
Yeah, good. Okay, now Vibha Karve, can you show that M&D problem which you are facing some difficulty?
Can you repeat, sir, please?
You are saying you have some doubt on that M&D problem.
Yeah,
no?
I got it done. I added the I removed that. I added again the in the add-ons. Then I got the solver and I managed to solve it.
Okay, good, great.
So and that is, this is how I got the reports.
Great.
So what is this E plus? What is this? Is it because
Infinity, madam. You click
okay.
on the numbers, go to the general view. ऊपर जाइए ना, buttons में जाइए.
Format cell?
Format cell.
Numbers, general.
Yeah, it is infinity. If it is a number, it will show some 1 lakh, more than 1 crore, something like that.
Shall I go
Number.
to numbers?
Yeah.
Yeah.
See, it's infinity.
Okay.
That is an infinity. Allowable increase is infinity if you are subject to coefficient with 7 and decreases is 8. That's how you will try to understand the sensitivity report.
Sure. Thank you, sir.
If someone can else share.
I will stop sharing.
Yeah. Yeah. Now,
Yes, sir.
we'll take one more problem and then I will try to. Various applications we are seeing. Okay.
Yeah.
Transportation, and then can you see my screen?
Yes, sir.
So this is something on advertising. Okay, advertising campaign, which they are designed to help marketing managers allocating a fixed advertising budget to various advertising media. Okay, so you have to maximize the reach of your advertisement. You have to increase the frequency. You have to enhance the quality of exposure. So there are some restrictions on the company policy, contract requirements, and the media availability. Okay, this is an advertising campaign planning where you can do the simplex linear programming, and then you can fit it in an Excel and you can solve it using the solver. So there is a developing a lakeside community at a privately owned lake. So this primary market includes all middle and upper income families within approximately some 100 miles of development. So we have employed the advertising firm of Boone Phillips and Jackson. It's one of the famous advertising agency for designing the promotional campaign, BP and J. So these are the things which we have in our hand as the data. Number of potential customers reached. If they have done it in some daytime TV for 1 minute at some station, it reached 1000. Cost per advertisement is 1500. Maximum times this advertisement available per month is 15. Exposure quality units are 65. Similarly, in the evening TV, 30 seconds. So this is the data which we have for the different TV, for the newspaper, Sunday newspaper, and at the radio. Now you should be able to model this using this LPP. We have an budget in our hand. We have the restrictions imposed. So you can have at least 10 television commercial must be used. 50,000 potential customers it must be reached, and it should not be more than $18,000 spent on television advertisements. So the decisions to be made is how many times to use this each medium, how many times I have to pick up this daytime TV, evening TV, morning journal, Sunday news press, and the radio station. Okay, that's the question in hand. So we have 1, 2, 3, 4, 5 decision variables. How many number of times this day TV should be used? How many number of times this evening TV should be used? Number of times this daily newspaper should be used. Number of times this Sunday newspaper to be used, and number of times radio to be used. We have to maximize the total exposure quality units for the overall media selection plan. Okay. So now we can do this as a linear programming model, exposure quality on various media using the various budgets which we have. 65, 90, 40, and 60, and 20 are the budgets, if you can see. Okay. Exposure quality unit 65, 90, 40, 60, and 20. And then availability of media with reference to PTV, ETV, PN, SN, and R, and overall budget, which is of $30,000. Now this we have to make a big problem, okay, big linear programming model, put it in the Excel. Okay, file name is relax, I guess. Try to run it and see the result. So these are the sensitivity report for the Enjoy Lake Development Corporation problem. Okay, so this is about some of the problems where we have seen from the manufacturing, financial, advertisement, and then transportation. You tell the scenario, or you tell the area domain where we can fit this transportation problem. Now let me share this Excel part again. Yeah, I think I have already done this. Please try to resolve it on your own, then we will see. These are my yeah.
Yes. Yes, thanks. Yes, done so.
1 second. No?
Done so.
Can you share your screen?
Sure, sir.
go to the answer report once.
Answer.
So finally, I should give 10 ads in DTV, and ETV should be 0. Evening TV 25 in the DN, and 2 in the place in the, and again radio in the T. Such that you can optimize your budget. So if you are seeing the budget, let us say the reach achieved is not binding when you are using this 61,500. There is an 11,500 is unused. Okay. And then TV ads, it's okay. TV budget used is also not perfectly used. Can you zoom it? Otherwise, I will show my answer.
Yeah.
Let me show my answer. Yeah. So if you see this,
Yeah.
these are unused 11,500, 3,005, and 10. Perfectly, it happened with this DN and the budget used, and then the number of TV ads that has been a binding. The remaining thing there are slack. You see 11,500, 3,000, 5 and 10. So you have to see how to make use of this, because the logic it has, it could not be able to go beyond this only 615, 15, and then 30,000. So if you look at there are infinity values, allowable increase with DN, allowable decrease with ETV, evening TV, as well as with the radio. So this is all about the transportation, descriptive analytics application in various issues. Okay, if you can pick up a case. Okay, I will run the software. We are at the end of the session. I have another half an hour. I will try to show it. Just try to follow. Let me see. I have this.
Sure, sir.
This is available. This is available. If you can open
Yes,
that par, if you can open that par problem and then tell me the values, I will ask. Okay.
Sure, sir.
Can you see this?
I can. Just 1 second, sir.
There is something called TORA, T-O-R-A.
In which report, sir? Answer
No.
report.
I'm sharing the screen. And could
Yeah,
you
yeah.
able to?
Okay.
So you open that TAR problem, golf problem in your Excel. You tell me the values. I will ask you. You tell me the values. Okay.
Okay.
So software I cannot share. Let me see. Yeah. Can you see this again? See here, linear equations, linear programming, transportation models, integer programming, network models, project planning. You can use a CPM critical path method and program evaluation and review technique. You can also solve the queuing analysis. Zero-sum games, that is of a strategy game theory problem. I will pick the linear programming problem. How many number of equations we have? 2. and then
Which
barring problem.
just 1 6 now. Can you repeat how many?
Unknowns are 2, na? 1, 2, 3, 4 constraints we have.
Yeah, in our yes, 4 constraints: cutting, dyeing, swing, finishing,
Yeah.
and
Yeah. Now let me 4. Okay, go to the input screen. It's not allowing to. Okay, this is a paring. Number of variables I said 2. Number of constraints 4. Okay, you enter the value. You tell me the variable name, standard,
very
variable
standard and
deluxe.
standard deluxe.
Okay, maximize how much? Standard 10, na? 9.
Yes, 10. Deluxe 9.
Okay. Now you tell me x1 how much? Constraints.
Constraint is 630. Oh no. It's 0.7.
0.7, yeah, perfect. 0.7.
Then 0.8.
0.8 less than or equal to, greater than or equal to.
Less than or equal to.
How much? 630, yeah.
630.
Okay. Second constraint.
0.5. Sorry. First is sorry, sir. The first here it is for the first is 0.7 and 1. Sorry, sir.
Okay. This is 1. Okay.
Yeah.
This one
0.5
0.5.
and 0.8. Next one is 0.8. And
How much?
yeah, this is 600.
Okay. Third one.
Third one is 1 and 0.6.
0.6. Okay. How much it is?
708.
All are less than, right?
Yeah, yes, sir.
Constraint 4.
0.1,
Okay.
then 0.25 and
Okay.
135.
135. Okay. Solve menu. It will ask to save. Yes. So it will ask to it will ask solving using solve problem using graphical or algebraic. It will ask, okay. Actually, I don't know why it is. Yeah. Click on the solve menu. So this is my final value. Objective value, if you can see, try to compare with your Excel value. 7775.17 will be my profit. If I can sell 568 standard bags and 231 deluxe bags, and we have some constraint, surplus also, sensitivity analysis, maximum objective coefficient, reduced cost. You can see all these things in this. Okay.
Yeah.
Very.
Here it is
Yeah.
76668 because we are not put that 0.35 and to the designations. So
Okay. So
yeah.
this is a more easiest way, right?
Yeah.
And again, if you want to change, you go to the media. Softwares are not allowed to share, I guess. So you can change these values here. You can change these RHS values, okay, and you can increase this
Yeah.
number of variables. So it's very easy. This is available freely on the Google. It is available with one of the popular textbook called AHA, okay, written by one of
Okay.
the US professors. Now, if you want, I will try to do main menu. Uh, yeah, we'll try to do the project. Can you tell me any question if that transportation model? How many sources? How many destinations? Let us say.
Sure. I
How
will.
many we have?
Transportation, what we used was
Clusters or anyone?
and just
Three
one
or
second. Foster.
three and
Yes. Foster is having um,
say Foster.
Foster generation.
4 and 4.
Foster generators. Parameters are 3. Then destinations are 4.
Now you tell me source destination name 1, Chicago.
No, the first one is Boston,
Okay.
then Chicago.
Okay.
This is Chicago. Then St. Louis,
St. Louis.
and then Lexington.
Lexington. Okay. And sources?
Cleveland,
Cleveland,
Bedford,
Bedford,
York.
York. Now you tell me the values also, please.
Boston is 3,
Okay.
2,
Okay.
7,
Okay.
6,
Okay.
and supplies 5,000.
5,000.
This is 6, 5, 2, 3, 6,000.
Okay.
It's 2, 5, 4, 5, 250. 2500.
Demand
6,000, 4,000, 2,000, and 1500.
so it will ask northwest corner rule, least cost starting solution, Google starting solution. Okay. So I will take up the northwest corner rule. So this is my answer. Can you see?
Yes.
Right. At fourth iteration, it is optimal. This is something. How much I got? Yeah, objective at 42500. I have optimized. The total cost is of transporting is $42500. Okay. This is how you can do it using some graphic user interfacing, but you should know how to interpret the answers. And you can also write to printer such that you can save this as in Word file. Okay. If you want me to that I have not saved. I think it lost. Okay, so this is how you can solve it. If you have any questions, otherwise I will show you another thing.
No, sir. Just one question. Can we
Yeah.
put that precise values over there?
Yeah, you can put no worries.
Yeah, so there is no restriction how it should be, the input should be, or,
Yeah, it has no restrictions.
okay, okay, okay. Thank you,
And
sir.
other thing is, I will show you that.
Because sometime, they don't, means like in Excel, how we are getting the reports, like you told me to change the cell address, isn't it? To
Yeah.
say the composition like that, I was asking, is there any constraint over here?
Not. We can.
Sure, sir.
Okay, this is also an interesting one. We can just have a look. Let me share it again. Yes. You tell me whether you could hear or not.
in Excel.
Sure,
First,
sir.
I'm going to click to the left of A
Can you
here
hear?
to select
Yes, sir.
all the
Yes, sir.
cells and reduce their width
Yeah, this
to
is interesting. Try to
make
solve
my
it.
inputs closer together. Next, I'm going to type the variables x and y up here. Then the objective function coefficients. Then for the constraints, I can type C1 here, grab the handle and drag down for C2 and C3. Input 4 to 4 for x, and then 1 to -5 for y. Then I'm going to put the signs here. Greater than for the first constraint and less than for the other two constraints. And then input the right sides of the constraints. For visual purposes, I'm going to select the constraints, right-click, and select all borders. Next, I'm going to find points for drawing the constraint lines. For constraint 1, I'm create a table for the x and y values. Highlight, right-click, and select all borders. So when y equals 0 in C1, x equals 12 divided by 4, which is 3. And when x equals 0, y just equals 12. For constraints 2 and 3, I'm just going to copy constraint 1 point here and paste for 2 and 3. And then clean it up a little. So for constraint 2, when y equals 0, x equals 9. And when x equals 0, y also equals 9. For constraint 3, we can write 4x equals 5y. So when y equals 0, x equals 0. And when x equals 0, y again equals 0. We already have that point, so we need another point. So we choose any point for one of the variables and then calculate the other one. For example, if we choose y equals 4x equals 40, so x equals 10. Now to begin drawing the graph, I'm just going to highlight constraint 1 here, then select scatter with straight lines and markers. Now I don't need the title, so I'm going to delete it and then resize the graph to my liking. Next, I'm going to right-click anywhere on the graph and click Select Data. I'm going to click on series 1 and click edit. For the series name, I'll just type C1 for constraint 1. Next, I'm going to delete series X values and replace it with 3 and 0 here. I'm going to delete series Y values as well and replace it with 0 and 12 here. And click OK. For constraint 2, I'm going to click Add, input C2 for series name, select 9 and 0 here for X, make sure the content of series Y values is deleted, and select 09. Click OK. Click Add again, and then C3 for series name, 010 for X values, and then delete this one and replace it with Y values. Then click OK and click OK. Next, I'm going to label the constraints by clicking on Insert, Shapes, and then Text Box. Click and drag and type C1 for the first constraint. Now press and hold the Control button, click and drag to copy the text to the other two constraints. Next, we find the feasible region. Note that C1 is a greater than constraint, so it is satisfied here above the line. C2 is a less than constraint, so it is satisfied here below the line. C3, however, is a little tricky because of the negative sign. To determine which region actually satisfies C3, let's pick a point and test to see if it satisfies the constraint. If we choose the point 40, for example, we see that 16 is not less than or equal to 0. So the constraint is not satisfied in this direction. It must be satisfied in the other direction. Judging by the direction of the arrows, we see that the feasible region is the region here. So I'm just going to Control click and drag C1 here and label the region feasible region. Next, I'm going to shade the feasible region. Click Insert Shapes and then select the Freeform tool. Next, I'll click on one of the corners, move and click on the second one, and the third, and then move my cursor to the beginning point to close it up. To make the shape transparent, I'll right-click on the shape and click Format Shape. Click Fill, then increase the transparency as desired. Next, I'll label the extreme or corner points A, B, and C. I'm now ready to find the coordinates of the extreme points. At point A, the two lines that intersect here are C1 and C2, so I'll copy and paste the constraints here. I'll also set up cells for X, Y, and Z where the coordinate values will appear. I'll color the cells for X and Y yellow and use green for Z. To find the coordinates at A, select the two yellow cells. Both of them must be highlighted for this to work. Then type equals mmult, that is matrix multiply, open bracket, then M inverse, open bracket, then select the coefficients, close bracket, comma, and then select the right-hand side of the constraints, and then close bracket. Don't just hit enter. What we do here is hold down the control button, and then hold down the shift button, and then press enter. And there you have it. That is the coordinate at point A. I'm just going to copy this and paste for points B and C. At point B, the two constraints are C1 and C3. So I'm just going to copy C3 and paste on C2 here. You can see that the coordinates are automatically adjusted to 2.5 and 2. We do the same for point C. The two constraints for point C are C2 and C3. We just copy them and paste them here. Next, we calculate the value of Z at each point. The objective function is to minimize 11x plus 3y. So we input 11 times the x value plus 3 times the y value. We then copy the cell and paste the formula into the green cell for points B and C. Since this is a minimization problem, the optimal solution occurs at point B, and it is x equals 2.5 and y equals 2. The corresponding minimum value of the objective function is 33.5. And that concludes this video. Thanks for watching.
So it's interesting, right?
Amazing.
Yeah, so if you can try the paring problem, it will be very nice. If you want, I can share this link of the video.
It's an honor to be to get such lecture from you, sir.
Thank you, thank you. These things, the same delivery we do for our MBA students, but we give more rigorous case studies. The cases will be more a bit tough, so they are supposed to solve it. Okay. So if you can solve that, or if you have any questions, we can I can take up.
Sure, sir.
Second.
So are you sharing your contact details?
Sorry.
Are you sharing your contact details? If any queries, we can ask email.
Yeah, you can take my email.
Share in the chat, sir. Will do.
Yeah, I'm typing.
Thank you, sir.
Actually, I want to show that Excel part. Where is this? Okay, this is what we try to do it using Excel as well. Okay, these are the lines which, if you parallelly put it on your x and y axis, where this optimal point at s is equal to 540 and d is equal to 252, my maximum profit line, which is of 7668. So if you compare using Excel, both linear programming and graphical solution, using other commercial, other free software that I have demonstrated, we have got the same answer, 7668. Okay, so this is how the prescriptive analytics look like, right? There's nothing more from my side. If you have, I can take any questions.
So far, so good, sir. We will hold the questions for some another session, definitely. It's too much to grasp. Thank you very
Right.
much.
Thank you. Thank you.
Thank you, sir. मी चालले Now I am leaving.